Yay, okay, here we go. So, this is my review for exam one for, what are we, the fall semester? Yeah, I think fall semester 2018 for engineering 1030, 1040. This exam apparently was given way back in the dark ages of summer of 2013. Wow, I've been doing this for a long time. Um, anyway, so just a few details on the exam. I don't know. I'm hoping it's on Canvas and you're aware of this already, but it is an open book. However, you cannot take your textbook in. The testing center will provide you with an electronic copy of the textbook. We've had too many students fill all the blank spaces in their textbook with notes, even though they're told not to write in their books. Um, so you'll get an electronic copy. You'll have 2 hours once the exam is open on your table. No notes, no old homework. You can use the help feature inside of MATLAB here, which you just type help and the command that you're wanting help with, and it'll give you a whole bunch of data in the command window. And if this isn't enough to satisfy your needs, you can always click on more down here to open up the documentation page. That is legal. We do allow you to use those help features. Um, the exam will be given to you in a live editor. So if you're not familiar with how the live editor functions, I highly recommend that you work with it over the next few days. It's really not that hard. This is very similar to what you'll be getting. Um, you just come at the end of here, just like it was an M file, and start typing in your code. And you can execute the same here, running one section or advanced. Difference here is it'll put the output back in the live editor rather than into the command window. You'll have the entire week for which to schedule a time to take the exam. You must schedule it with the ITC. There is a link on Canvas, and you also need to take your one card with you in order to gain access to the exam. That way that you're not sending a ringer in to take the test for you. I think that's everything I need to cover for the exam. So I have seen the exam, I have worked the exam, I have edited the exam. There were some errors. I think it's a well-written exam. It's not so hard that only top 2% of the class will pass it, but it's not so easy that you're going to breeze through it without having to think. It should be a fairly good average for this exam. It is quite easy. Well, not quite easy. Well, yeah, I guess quite easy if you've been doing this for 100 years. So anyway, this exam was taken from the summer 2030. 2030. Wow, I got in my TARDIS and went forward and got this exam and came back and presenting it to you. I will post the blank version of this on Canvas, as well as my solutions from tonight, and also I am recording and will create a video to upload to YouTube and also provide the link for that. I will also provide a second exam that I have not worked with its solutions on Canvas. Hopefully I can get those in either tonight, tomorrow night, no later than Saturday night. Okay, so I am going to work this exam. I gotta take this off first. It'll drive me nuts. That's a very short ride. Yes, it is. Okay, so problem number one. The surface area of a cylinder is found with the following equation. Surface area is 2 pi times r squared plus 2 pi times rh. Find a surface area with the range of radius from 2 to 10 with increments of 2. And vary the height. Okay, I don't know, I did write this. And vary the height from 10 to 24 with 6 values. Hint, you must use MeshGrid for full credit. Also set the output format to allow MATLAB to select the best short format. Okay, so we will begin by creating a radius vector, and it is going from 2 by 2. Come on, you can do this. To 10. and our height is going to be from 10. Oh, it's going to have 6 values, so we're going to use the linear spacing function, and we're going to start at 10, go to 24, and have a total of 6 values, and we're going to suppress the output. And then we need to do a mesh grid here because we have 2 different size vectors. So oh, excuse me, I'm going to cheat so I can copy. I'm going to call that R and H now, and that's going to equal mesh grid, no O in grid, of rad and height. What is it with all these O's, man? I must have had a cell at the store or something, picked up an extra package. And then we'll just cheat and borrow this equation up here so I don't have to write it and make all kinds of mistakes, and fix the areas that need fixing. Surface area is going to equal 2 times pi, and this is now a matrix, so we have to use the operator and multiply, and again a matrix, so we have to use the element operator, and that should give us a matrix answer. Boom, there it goes. And so there is our answer for part 1. Okay, pretty straightforward, pretty easy problem. If I go too fast, tell me to slow down. I'm just gonna go and babble while I do it. Okay, problem 2. I like to hopefully get my students into the habit of clearing their variables before they start a new problem, unless the next problem works on the first one. Okay, the data file bearlake.txt contains the level of the Big Bear Lake in California, not the little one in Utah and Idaho, taken the first week in January for the past 10 years. The first column is the year the reading was taken, and column 2 is the elevation of the lake in feet. Use the load command, and whoa, there's a lot that didn't do that on assignment 4. Load the data into MATLAB. Okay, let's make sure that I'm in the current folder. I'm not. Let's see, this was, I think I got it out of summer 2016. Where did I get that from? Yeah, it was summer 2013. Wow. Okay, so where is it? Okay, here we go. Exam question. Okay, there's the Big Bear Lake. Okay. So now my data file is in the current folder, and we're going to just load it by copying the name of the file with its extension, and then get out of here. Part B is find the year that the lake was at its highest point. So we're going to do a max level and its location by assigning 2 outputs to the max function. We get the maximum value and where it's found, and we want to find of Bear Lake, but we only want to find column 2, so we're going to look at all the rows in column 2, but that wasn't even close to what we wanted. All the rows in column 2, and we'll suppress that and then take the year at max level is going to equal, again, Bear Lake, oops, there's an L in lake, you idiot. I know that, leave me alone. And we're going to look at all the rows in column, oh no we're not, we're going to look at the location in column 1, and that should give us a year, 2011. I'd have to open the data to find out. Well, let's look at the data. Whoops. So the maximum here 274, 2740, 2742 right there. There's the maximum value at 2011. So that is correct. Okay, problem number 3. Determine the sine cosine of x and create a table of data for each of the following. Okay, so x is going to be from 0 by pi over 4 to 2 times pi. And if you guys have questions as I'm going, by all means ask them. X representing 9 Gaussian numbers with an average of pi and a standard deviation of 3. Okay, so let's do part 1A here first, or A1. This is going to be A1. So, and then I'm going to cheat and do a table of x, and I'm going to transpose it so that it's going down. And we want the sine of x and the cosine of x, and then yes, I know there's supposed to be single quotation marks on both sides of that. X, oh no, let's do theta. Video. There we go. So there's our sign using part 1. Now if we go to A.2, it wants us doing x is equal to a random number average Gaussian random numbers with an average of pi and a standard deviation. So so we want 9 numbers. Then we're going to multiply that by our standard deviation and add our mean value, and then we're just going to cheat, and because it's the same thing, the only difference was the creation of okay, and just so we can prove that that has our mean and our standard deviation required, we'll just have it calculate those two. So our average is near pi and 0.4, so not bad for only 9 numbers. Oh, look at that, I did it up here. That was part B down here, sorry. That's what I get for not reading ahead. B-bunk. Oh, somebody else has joined me. Welcome. You'll have to watch the video to see the first 3 parts. Problems. Okay, and these are going to change every time you run it because they are random numbers. Okay. That was embarrassing. I mean, done. Okay, so this one, problem number 4. Weight is measured of the gravitational force between 2 objects, which depends on both the masses of the object and the radius between the 2 objects. Because both of the masses and the radii of planets differ, the weight of a given object on Earth will vary on different planets. The following table shows the ratio of gravitational forces on other planets relative to Earth. Relative weight equals weight times g. Okay, so first create a column of gravitational okay, so So we're gonna have a gravity here is gonna equal, and then we got 1 point aught aught. And stop me if I get a wrong number in here, guys, okay? Because 38, 0.91, oops, 0.38, 2.54. Where to put? Oh, there it is. I'm just gonna mute you guys. If you have questions, just
Everyone else is now muted.
if you have questions, just type them into the chat window. I will see them and answer your questions. The background noise was getting a little heavy there. 2.4, so 1.08, 0.91, 1.19, 0.06, and 27.9. So there's our vector of gravitational constants. Okay, so use the ability to perform the following computations. Okay, compute the relative weight of a person on each planet. Bidonk, oh, somebody just left me. I'm sorry. We're going to have the weight of our body is 150.5 pounds. And then the relative weight is going to equal to the weight times my gravity. And that should give us a vector of weights. Does it say how to output that? It don't. So if you did this, this would be fine. If you want to get carried away and do an fprintf to display it nicely. And y'all know about the fprintf, the little placeholder here, right? So if I do a 5.2 f, that tells MATLAB to hold wait, oh, I'm not used to this. Here we go. It was the wrong color. To hold 5 places, including the decimal point, 2 of which on the right side will be on 2 will be on the right side of the decimal. Okay, and then we'll come over here and do another, do a 6.1 f, and then a new line, and then we'll create a thing in here. We want the gravity to be in the first one, and we probably ought to do headers too. Yeah, that would probably be nice. Relative gravity. Yes, I talk to myself all the time. Sorry. Hope it's not too confusing to you guys. Let's do a display and have it display the gravity and relative gravity. What? Oh, relative weight, you idiot. Man, I tell you, some days it doesn't even pay to get out of bed in the morning. No, relative gravity, relative weight. Okay, and see how they're all jagged? If you want to make these all line up on one side, like on the right side, you find your longest one here. So that's 1, 2, 3, 4, 5, 6, counting the decimal point. So if we change this one to a 6, and then this one here is probably based off of the fact that that one's all wiggly woggly. So what happens if we run it? See, by lining that one up, it lined this one up over here. If you use a tab instead of spacings, that wouldn't have happened. I like to use the spacings because I can, a few modifications, center it up. But this wasn't written in the question, so it's not required. Okay. Ow. Oh, okay, so now we want to sort in descending order. Okay, so let's have a here sorted is going to be equal to sort our relative weight and we want it to go negative, so we are going to descend, and that should give it to us in negative order. Cool. And again, if you wanted to go through the trouble to do this, you could. It's not required because it just said to do it. Round the sorted weights to the nearest integer. Okay, so we're going to round round the sorted weights, so we called that sorted, right? And that brings it up to the nearest integer. Number 5, put the sorted weights and their rounded weights in a table, 2 columns. Okay. Well, let's do it the other way. Let's create. We're going to redefine the table function and call it table, and you can also do it this way. So we had sorted, and we want them. They're going down, so we just want to put the next one, which is rounded, next to it, and that should give me a. And you could also do that with the table function if you wanted, although I just redefined it, so it doesn't work no more. Find the average weight and the weight in the middle of the range of, for both columns in the table. Okay, so that's easy. Average is not spelled with a B, at least not. Whoa! Oh, hang on. Hi, Paige, baby. I'm online with my students. I'll call you back when I get done. Bye. Sorry, it's my girlfriend. Just don't tell my wife she called. So the average is just going to be the mean of our table, which will return 2 values, which will be the mean of each column. And then the midpoint is going to be the median of the table, which will also return 2 values, which will be the median for each column. So if that would be the average, and if you looked at the middle here, you'd see a 136.9, so that one must be in the middle. One of those two. Add those two. Okay. Okay, sorry, there is a question here. Why did I put the variable names in square brackets for the FPRN, but the earlier problem you made the table, you put them in? Okay, that's 2 different functions here. Up here, when I did this table, where is it here? I put the names in the squirrely brackets just to have the names up here. If you don't do that, it just does the naming your variables, and I didn't have names here, so I named them. But down here in the fprintf, this is basically creating a matrix within the fprintf, and that's the same thing that I did down here on this other problem right here, the square brackets. You use the square brackets to create vectors or matrices. Um, does that make sense? And also on this up here, you need to make sure that when you build this matrix, oh, see, and that, see, you guys didn't catch, I didn't catch it either. If you'll notice here, this is listing all of the gravities before it's doing the relative weights. And that's because I had 2 columns instead of 2 rows. You need 1 row for each one of these placeholders. So we need to turn these, so I need to turn that into a row vector and turn this one into a row vector, but now that's going to give me one row and a whole bunch, so I need to do this one so it goes underneath. So this here should have as many rows as you have placeholders. So I have 2 placeholders, so I need 2 rows. So now if we run this, that looks a little more gooder. So this is listing all of the gravitational constants and the relative weights. I know that wasn't your question, but did it answer your question? I hope. Okay, cool. So yeah, when you're doing multiple characters, you use the curly brackets. When you're building matrices or vectors, you use the square brackets. Okay, cool. I hope. I'm sure somebody will watch this video and say, he don't know what he's talking about. This is what it's supposed to be, and it could be. Okay, problem number 5. Create a matrix with the following values in the first row, second row, and third row, and call it A. Okay, so here again we'll use the square brackets. So we got 1, 2, 3. Oops. You gotta have at least a space, or if you so desire, a comma. Either one is valid. Okay. So create a matrix with the following values in the first column using the A matrix and the diagonal command. Create a matrix with the following values in the first column using the A matrix. Okay, I guess that don't make sense. A matrix has more than one. Okay, well, I think it's just asking us to pull out the diagonal of it, and if it wants it to be a column, we'll transpose it. So now it's a column in the first column. Combine matrix A and matrix B to create matrix C, 2-dimensional 4 columns and 3 rows. Okay, so that's easy. C is equal to A, no it's not, it's equal to A und B. And because we transposed up there, we don't need to transpose down there, I hope. Let's see, no, yeah, okay, so there we go. That automatically comes out as a vector, or a column vector. And then finally D is create a row matrix D with the first element equal to the third element in the first row, C is going to be the third row, fourth column, and B the second row, first column. 139. Okay. Problem number 6. Heat transfer by conduction can be used to model heat loss through a wall. For a 9 meter square concrete barrier with a change in surface temperature of 7 Kelvin that has a constant thickness, the rate of heat loss is given by heat conduction is equal to 0.8 times 9 times 7 divided by thickness. Is that divided by thickness or yeah, and that's all in meters. Given the equation above, create a plot using the f-plot function that represents the change in heat conduction relative to wall thickness for a concrete wall. Plot your graph for the values between 0.5 and 2.5 meters. Title the graph and label your axis. Okay, so we need an equation, and this is going to be an anonymous equation. So it's going to begin with one of those, and our thickness is going to be our variable, and then it's going to equal 0.8 times 9 times 7 divided by our thickness. Okay, and then we're going to do an f-plot of our equation from 0.5 to 2.5, I think, right? Yeah. Does that work? Warning. Warning. Danger, Will. Danger. Okay. So, in case you're curious what all this information here is, the 0.8 is this part of the equation, and the 7 comes from the change in temperature. If you subtract those two, there's 7 degrees Kelvin difference. But I think we just put that in there to confuse the students. So we're going to title this heat transfer X. What was X? Thickness. X. Label. Wall. Thickness. Y. Label. It was something. I don't know. Okay. Something. Any questions, comments, wants, needs, desires, concerns? Hopefully no complaints. Too early for complaints. Okay, so problem number 7 is create a function called f to k that converts temperatures in Fahrenheit to Kelvin. Use your function to generate a conversion table for values from 0 to 200 Fahrenheit spaced by 40 degrees. Okay, so we're going to borrow all this and come down here and create a function that has some output, and it's called F2K, and this is stuff that you're working on right now, and it's going to have one input, which is going to be Fahrenheit, and then I like to bring this information down so that I can, normally these things are up at the top of the exam, not the last question. So our output is going to equal our input minus 32 divided by 1.8, and then all of this is going to be added to 273.15. Very important on functions in the live editor. It must have an end statement. If you're doing them in separate M files, this isn't required, but if you're doing it in the editor, you definitely have to have the end statement. So, okay, so you just create a table. Okay, so we're going to create a really cool table this time and make it pretty and all that other good jazz. So we're going to have our Fahrenheit is equal to 0 by 40 to 200, and our kelvins is going to equal our F to K of RF. And then we're going to have a display function, not a period, Fahrenheit and Kelvin, and then we'll do an F print F. So our Kelvin is gonna have 200, 400, so I'd say probably at least 6.2 F, and then those aren't kelvins, those are Fahrenheits, you dummy. So we'll do our 6.2 F here, and our Fahrenheits are all even numbers, so it's going to be 3.0. There's no decimals because we defined it from 0 to 240s. Do our page return, come in here and create our thingy here, F and K, and I think 0483. No, that's not right. So we got to what? Oh, because you didn't do 2 rows, you had one long column. Okay, that should be 2 rows. It's not. So that's the problem. I was right, but I was wrong. They are currently row vectors. There we go. So now we got our 040 to 8200, and there's our conversion. Because see, these came out as rows, and I transposed them to columns, and I didn't need to. Oh, see, this output came up here because I didn't suppress it in my function. So if you don't want your output in your command window, you need to suppress it in your function as well. And the final part here, part B. Oh, 40 minutes, that's not bad. Create an anonymous function to convert pressure in pascals to pressures in atmospheres. Call the function pa to atmos, and this should be familiar to you guys because we had an assignment that this came from. So we're gonna have 101,321 times Pascal, and we're going to suppress that, and it didn't say to do anything different than that, but we'll just go ahead and test it the same way we did up here. Only we're going to go, hey, where did you go? And change this to PA. see, there's 6. So we shouldn't have any on that side. And let's hope it works. And we got problems again. Why are you guys so... Oh, because that's supposed to be a semicolon. There we go. There we go. Okay. I should have made a disclaimer at the beginning that I'm not perfect. I can't work my way around these things. I don't know this stuff well enough to... Well, I know it well enough to teach it, but not to make mistakes as I'm going along. Any questions? I will unmute you guys now because that was the last of it. If anybody's left, I think everybody left me.
Everyone else is now unmuted.